compounding interest. Alright, so these are the formulas that we have already talked about. So we had an increase formula, and a decrease formula. But that's called simple interest. Now we're going to learn about compounding. Can you let her in, Grandma? Please. And that is going to put a new variable in our formula. Oh, of course.
Well, I think the perfect one. There we go.
N is the number of times compounded. So we'll see that word in our notes today, or in our examples. And there's going to be different numbers that we use for number of times compounded. So we might see daily, N is going to be 365. Monthly, N is going to be 12. So it's in 1 year. Let's add that. Quarterly, N equals 4. So here's the formula. 8, Let me pause for a second.
Yes, please.
Okay.
Thank you.
Mm-hmm. So the formula is going to be similar to our increasing formula, but it's going to add that N variable actually in 2 places. So it's P times 1 plus So R is going to be divided by the N, close parentheses, and up in the exponent, N is going to be multiplied to time. So we've introduced this variable in two different places in this formula. Because on the bottom and up in the exponent. All right, so let's take a look at some problems that involve compounding. Jeremiah invested $3,250 in an account paying an interest rate of 2.6% compounded monthly. How much will he have after 7 years? To the nearest $10. So I'll give you a minute to write that down, and then we'll talk. Yeah. Okay. So, our initial investment is $3,250. Our interest rate is 2.6%. And then it says compounded monthly. So that tells me what I'm going to use for N, and then after 7 years. Okay, so the formula, A equals P times 1 plus R over N to the N times T. Yeah, go ahead. So P is our initial investment. Of $3,250. 1 plus. Please don't forget that you have to change this percent by dividing it by 100 before we put it into the formula. So you take the given and divide by 100. It should be 0.026. Oh, I shouldn't write it right here. Oh no, I just get messed up. .026 divided by compounded monthly. It's 12 months in a year. So N will be 12. Good job. To that, so we're also going to use that N up here in the exponent. 12 times 7. Exactly. Hey, hey. Here's my calculator.
3,897.99.
That sounds good. 3250. 1 plus 0.026 over 12 to the 12 times 7. All right, so he says $3,897.97. But, so I'm just going to write that down. 3,897.90. Actually, we'd round that 7 to an 8 if we were rounding correctly. But, but in Delta Math, for whatever reason, I don't know why they do this, they're going to tell you a couple of different things. So you're not always going to be rounding the same way. So this one, they asked us to round to the nearest $10. So we're looking in the tens place. And actually, that's going to bump the 8 to a 9, right? Mm-hmm. Okay, so I could have done better on my numbers. But, so since I'm rounding the tens place, I'm looking to the number next to it. It's a 7. So that's going to round that 9 to a 10, which will actually bring that to a 900. So you have to be careful about what they ask you to round it to. Because they're going to say to the nearest $10, to the nearest cent, to the nearest dollar. They're going to be changing it up on you. Okay? Hello?
Yes.
Okay. All right, let's do another one. So I'm going to write our formula down. A equals P times 1 plus R over N to the N times T. Okay. Justin invested $25,000 in an account paying 2.1% interest. Compounded quarterly. How much will he have in 8 years? To the nearest cent. So I've got the initial investment, 2.1%. It's compounded quarterly. Oops. In 8 years.
I need to write this.
Okay. Sounds good. How do I know if my answer's right-ish? If you put money in the bank, do you feel like you're gonna make like $1 bajillion after that? What do you think? You think a reasonable amount of money after 8 years might be $4,000?
Thank you.
You're welcome. Yes, the answer is yes. All right, so we'll talk about that in just a second, I guess. P, your initial investment is 25 grand. So A plus 25 times. It's always a 1 plus. We have to change this percent to a decimal by dividing it by 100. It's going to move the decimal 2 places to the left. If you watched that Ed puzzle yesterday, that's kind of what I talked about. Over, it says compounded quarterly. So you can think of that as there are 4 quarters in a dollar. So there are 4 quarters, or 4 quarters in a year. Like in a semester, there's 2 quarters. So in a year of school, there's 4 quarters. To the 4 times 8. It'd be really nice if you had one of these like yellow or black calculators. But I believe you can do all of this on Desmos calculator. 1 plus 0.021 over 4 to the 4 times 8. Okay. So, Jeremiah, what'd you get? 0.4, give me one more.
I deleted it.
0.42. So they want to the nearest cent. So you have to give them 2 decimal places. So you have to be looking at what the problem is asking you for, if you need to round, when you need to round, how many numbers they want. Because Delta Math's going to be very specific about how many numbers you put in for your answer. They will mark it wrong if it's not rounded correctly, if you gave them too much. So be aware of that. Okay. What? Yes. This one is because the number to the next was a 1. So it just stays the same. Okay. So, how's that going? Easy. Okay. I've got one more thing to show you. And it's called compounded continuously. It's going to change our formula just a little bit. A equals P times E to the RT power. E is not a variable. It is a button. And it lives on top of, it looks like an IN, but it's an LN button on most calculators. So this is an LN. It looks like IN, but it's an LN. And right here, I can see E. Right there. You see the E?
Where would we find that on the, if we have like a black calculator?
I used to have a black calculator. I don't know what happened to that guy. Hang on.
Found it.
Oh, okay, good.
Oh,
It's on there somewhere. Is it on the LN button? Do you find the LN?
No, it's a special button.
Oh.
It's E with the little square where the exponent goes.
Yes. Awesome. So, yeah, you got to find the E, and we're going to use that button today for this. So, I'm going to give you an example. It says, Daniela invested. $10,000 in an account. Paying 6.1% compounded continuously. How much money will she have in 6 years? To the nearest dollar. Alright, so I'll highlight the important information. So because it says compounded continuously, there's no number that really represents continuously. So that's why we have to use this different formula. So A will equal 10,000 times E and we're going to have to change the rate by dividing by 100. Yep. So we put the rate up here in the exponent, 0.061 times the years. So both of those pieces are in the exponent. If you're using a graphing calculator, you need to put those pieces that you're putting in the exponent, they need to be in parentheses. Otherwise, you're going to get a hot mess for an answer. So we'll do 10,000. So to get the E, anything in green, I have to press the second button first. I'm going to put 0.061 times 6. So after 6 years, compounding continuously, she should have 14,400 and, oh, it did it again, dang. All right, so they want it to the nearest dollar. To the nearest dollar. So I'm looking right here at this 9, but it's going to have to round up because of this 5. So the 5 pushes the 9 to a 10, which is going to make that a 20. So be careful when they ask you to round to the nearest dollar or to the nearest cent. If they want you to be precise. All right, so